Hello, this is Miss Moore, and today during chemistry, we'll be discussing significant figures and calculations. Before we get started, if you do not have your calculator handy, go ahead and hit pause and go grab it, come on back, because we're going to be doing some calculations together. Okay, here we go. Significant figures and calculations. Today's essential question, how are significant figures determined when using calculations? A calculated answer cannot be more precise or exact than the least precise measurement. A calculated answer is simply a number obtained by doing a mathematical calculation, multiplying, dividing, subtracting, adding, numbers coming from measurements. So the answer cannot be more precise. You cannot have more confidence. The answer cannot have more significant figures than the original measurements. So we have some rules to follow to ensure that our answer is not more precise, that our answer does not have more significant figures than the measurements themselves. Let's start with multiplying and dividing. So when multiplying and dividing, the answer should be rounded to the same number of sig figs as the measurement with the least number of sig figs. Remember, we do not want our answer to have more significant figures than the original numbers. We don't want to be more confident in the answer than we were with the original measurements. Okay, let's try a quick multiplication problem and practice this. So we'll multiply 3.06 times 21.33. And if you could plug that in your calculator along with me, make sure we all agree on the answer. I came up with 65.2698. As you can see, the calculator gave me an answer with more significant figures than either one of the original numbers. So we're going to have to do some rounding. The first thing we want to do is figure out how many sig figs, or how many significant digits, each of the numbers in the original problem have. So we'll start with 3.06. How many significant digits does 3.06 have? I say 3 sig figs, because the 3 and the 6 are significant because they are non-zero digits, and non-zero digits are always significant. The 0 is significant because it's between non-zero digits. All right, how about 21.33? How many sig figs does that number have? I say 4 sig figs because they are all non-zero digits, and all non-zero digits are significant. All right, so now we know the number of sig figs in the original problem, 3 and 4. So how many sig figs should the answer have? Well, the answer should be rounded to the same number of sig figs as the measurement with the least number of sig figs. That means our answer should have 3 sig figs, which means we're going to keep the first 3 numbers, which means we've got to do some rounding. So let's do a little bit of rounding practice just in case. So when you're rounding, you start by looking at the first number you're going to drop. Okay. If that number is 5 or more, you round up. If the number is less than 5, you drop. Okay, in this case, the number we're planning on dropping is a 6, which is 5 or more. So our final answer, including appropriate sig figs, is 65.3. Let's try a division problem next. Let's divide 2.55 by 152.33. And again, if you could go ahead and put that in your calculator, make sure we agree on the answer. My calculator gave me an answer with a whole lot of digits. I got 0.016739972. Okay, my answer has a whole lot more digits in it than either one of the original numbers. Okay, so the next thing we need to do is figure out how many sig figs are in each of the original numbers. So 2.55. How many sig figs are in that number and why? I say there are 3 sig figs because all of those digits are non-zero digits and all non-zero digits are significant. All right, how about 152.33? How many sig figs in that number and why? I say 5 sig figs because, again, all of those digits are non-zero digits and all non-zero digits are significant. All right, so now we need to figure out how many sig figs should be in our answer. Remember that when you're multiplying or dividing, the answer should be rounded to the same number of sig figs as the measurement with the least number of sig figs, which means our answer should have 3 sig figs. All right, let's look at the answer. And before we can even figure out where the sig figs are, we need to review some of our sig fig rules. So if we look at this 0, could that 0 be a significant figure? Remember, for a 0 to be significant, it either needs to be between non-zero digits, which is not the case, or it can be before or after a decimal, but there needs to be a non-zero digit before the 0, which is also not the case, which means that first 0 before the decimal and that first 0 after the decimal cannot be significant. So our first 3 sig figs are 167. All right, so we're going to be dropping everything from the 3 on. One more time, let's review the rounding rules. If the number you're going to drop is 5 or more, what do? Round up. If the number you're going to drop is less than 5, what do? Drop. Okay. In this case, we're looking at a 3. The 3 is less than 5, so our final answer in appropriate significant figures would be 0.0167. Okay, so we have 3 sig figs, and plus those zeros at the beginning, which are not sig figs, they're placeholders. Before moving on to addition and subtraction, I'd like to do one more multiplication problem to point out a potential point of confusion with sig figs and rounding. So we'll take 18.3 multiply by 4,200. So if you guys could put that on your calculators and check me, I got 76,860. Okay, so let's go back and figure out the sig figs for our numbers in the question. For the first number, 18.3, all of those are non-zero digits, which means they're all significant, so we have 3 sig figs. Okay, for the second number, the 4 and 2 are significant because they're both non-zero digits. The zeros, are they significant? Are they between non-zero digits? No. Are they before or after a decimal? No. So they're not significant. So the second number only has 2 sig figs. So our answer is going to have how many sig figs? 2. Okay, which means we're going to keep the 7 and the 6, and we're going to look at the third number here, which is the 8. And it's 5 or more, which means we round up, which puts our answer at 77. Hopefully you guys can see a bit of a problem here. 77 cannot be a rounded version of 76,860. They are completely not the same numbers. All right. So when you have a number and you're doing rounding and there's no decimal, you need to put placeholders in for all the numbers that you're going to drop or round. So basically think of it as rounding down. So we're going to put zeros as placeholders. Now, 77,000 can be an appropriate rounded version of 76,860. Let's switch gears a little bit now and talk about rounding calculated answers when adding and subtracting. Okay, when adding and subtracting, the answer should be rounded to the same number of decimal places as the measurement with the least number of decimal places. Okay, so this time we are not going to be counting number of significant figures. We're going to be counting the number of digits to the right of or after the decimal. Let's try an addition problem. How about 3.06 plus 18.2? Okay, if you put that in your calculator with me and check my answer, I got 21.26. Okay. Now we need to figure out how to round the answer. Remember, this time, because we're adding, we're not going to count the number of significant figures. We're going to count the number of digits after the decimal. So here we have 2 digits, and here we have 1. So how many digits after the decimal should our answer have? Well, it should be the same as the number with the least number of decimal places, which is 1. Okay. So we're going to be keeping the 21 and 1 digit after the decimal, which is the 2. So we're going to be dropping the 6. So when you're dropping a 6, for rounding, what do? It's 5 or more, right? Which means we need to round up. So our final answer is going to be 21.3. Let's try a subtraction problem. Let's take 896.75 minus 18.588. Okay, once again, put that in your calculator. Check my answer with yours. And I got 878.162. Now we got to figure out how to round our answer. Remember, because we're subtracting, we're looking at the number of digits to the right of the decimal, not the number of sig figs. All right, so if you look at the first number here, we have 2 digits after the decimal, and the second number has 3 digits after the decimal. So how many digits after the decimal should our answer have? It should have 2, because the answer should be rounded to the same number of decimal places as the measurement with the least number of decimal places, which means we're going to keep the 878 before the decimal and then the 1 and 6 after the decimal. So we need to figure out what to do with the 2, how to round. Our 2 is less than 5. So what do we do with a number that's less than 5? We drop. Okay. So our final answer is going to be 878.16. Okay, that's it for significant figures and calculations. If you're feeling comfortable with this, go ahead and continue. We've got a few practice problems to do. If you're unsure about this, why don't you rewind, rewatch, and jot down any questions that you have so that we can discuss it. Now, let's see if you've got it. Go ahead and solve these 4 problems, making sure that you write your answers with the appropriate number of sig figs. Okay, so hit pause, go through these. When you're done, I have the answers for you. For number 1, I came up with the answer 74,000. Okay, let me go through step by step how I came up with that answer. First thing I did was put 33.7 times 2200 into the calculator and came up with an answer 74140. Next, I determined the number of sig figs in the original numbers. So how many sig figs are there in 33.7 and why? I came up with 3 sig figs because 3, 3, and 7 are all non-zero numbers, and all non-zero numbers are significant. How many sig figs are there in 2200? I came up with 2 sig figs because the 2 and the 2 are both non-zero digits, they're both significant. The zeros, on the other hand, are not significant. Remember, for a 0 to be significant, they either need to be between non-zero digits, which is not the case, or before or after a decimal. There's no decimal there. The zeros are not significant They're merely placeholders. So, how many significant figures should be in my final answer? Remember, it needs to match the number with the least number of sig figs, which means my final answer needs to have 2 sig figs. So that would be the 7 and the 4. So if we look at the 1, which is the first number we're going to drop, the 1 is less than 5. And what do we do with a number that's less than 5? We simply drop it. Okay. What some of you may have wanted to do is write the answer as 74. However, the number 74 is nothing like our answer here. Okay. Furthermore, it's not possible to get a number 74 when multiplying 33.7 by 2200. So while 74 are our 2 significant figures, we need to add 3 zeros as placeholders. These zeros are not significant. They don't follow the rules for zeros being significant. Okay? And that is how I came up with that answer. For number 2, my final answer was 10.9. Again, let me go through step by step how I figured that out. First, I put 18.25 divided by 1.67 into my calculator, and I put in 18.25 first. My calculator spat out the answer 10.92814,371. Next, I figured out the number of sig figs in each of the original numbers. The first number, I got 4 sig figs because they are all non-zero numbers, and all non-zero numbers are significant. And for the second, I got 3 sig figs. Again, they are non-zero digits. All non-zero digits are significant. So how many digits, sig figs, should be in my final answer? 3, which would put it at these 3. Okay? So everything after the 2 is going to go, and the 2 is less than 5. So we're going to go ahead and drop, which puts our final answer at 10.9. Now this time we really just drop the numbers, because dropping numbers after the decimal does not change the value of the number. For number 3, I got a final answer of 20.2. All right, so let's go through that one real quick. First, I put in my calculator 12.1 plus 8.11, and I got the answer on my calculator 20.21. Remember, this time, because we are doing addition, we're not looking at sig figs, we're looking at the number of digits after the decimal. 12.1 has 1 digit after the decimal. 8.11 has 2 digits after the decimal. So our final answer should have 1 digit after the decimal. So we're going to keep those 3. We deal with the 1. The 1 is less than 5. So we drop it, giving our final answer at 20.2. And again, we don't have to add a 0 there because it's to the right of the decimal. It doesn't change the value of the number. For the last problem, I got a final answer of 13. So how did I do that? I put 28.159 minus 15 in my calculator, and received an answer like 13.159. Okay. Again, we're doing subtraction, so we're not looking at the number of sig figs, we're looking at the number of digits to the right of the decimal. So 28.159 has 3 digits, 15 has none. So how many digits should we have after the decimal in our answer? None. So we're going to keep those and get rid of all of that. So we look at the 1. It's less than 5. So we're going to drop it. leaving our final answer at 13. Okay, that is the end. If you feel comfortable, great. If not, again, review what you need to review, write down any questions so we can talk about it.